You're a pilot, you're an aerospace engineer, and you have done something called a hands-off flying experience. Now, I'm not a pilot, but when I fly, I have a hands-off experience every single time. So please tell us what you mean by this.
Well, that's true. As passengers, always you have a hands-free experience. But, and maybe I can show a picture. We gave pilots a hands-free experience of flying airplanes. I'm not sure if we can see the image, the photo, but we placed pilots into our flight simulator at the Institute of Flight System Dynamics at Technische Universität München, and exactly that was the picture. There it is. And as you can see, the pilot does not touch the controls with his hands. He has a strange cap on his head. So this was a project called Brain Flight, and we tried to steer airplanes with brain signals only, not by touching controls, not by moving levers and control sticks, but only with, well, the power of your thoughts. Although this is not thought reading, this has to be stressed. It's really down-to-earth signal processing, and you can observe some brain activity patterns, and you can associate them to certain aircraft reactions. And when you do that, well, people sometimes have control. And I have a video here which shows how, oh yeah, there it is, great, how one pilot succeeded in controlling the airplane. So this is an approach to Munich Airport, simulated Munich Airport. It's in the simulator. The up and down movements are controlled by an autopilot, and the left and right movements are controlled only by the brain signals. So you can see it's not working perfectly. There's still some errors. It's going left and right and left and right. You can see on the bottom right the control stick moving by its own. But this subject managed to, well, reach the runway pretty well. Others did not really have control. This has to be said. So this technology is not yet working perfectly, but this is a first step. The project really was not immediately to create an airplane that can be brain controlled, but also to just start a dialogue, an interdisciplinary dialogue between engineers and neuroscientists, and bring something to work like this, which just shows that the brain control thing is working, right?
It's equal parts awesome and terrifying, I have to say. Why would you want to do this? Why would you want to fly with just your brain activity?
Well, yeah, as I said, there's the long-term vision, the brain-controlled flight, and this is maybe not something that you will see in the near future, and there's other goals in between. Obviously, what could be interesting is you have the flying controlled with your brain, so you can do other things with your hands, or as well you can have physically disabled people becoming pilots. But before doing that, obviously you would apply this technology to all kinds of other stuff. And we just heard about exoskeletons and the kickoff of the last World Cup, which was accomplished with this technology and an exoskeleton. So the combination of those two. And this is obviously a great help for physically disabled people.
So how exactly does the technology work? You said it's not thought reading, so I still have to be a pilot, right? I can't just put this cap on and think really hard and then fly your simulator?
Right, so when we speak about flying airplanes with this technology, you would still have to have some training, obviously. There's also, well, flight-related training, and there's also some training related to the brain control technology, which is based on the one hand on machine learning. The algorithms have to recognize, well, the brain patterns, the brain activity patterns that you create, and you have to learn how to create them.
Mm-hmm. Is there any chance that the technology could misread a brain signal? Say I'm trying to say turn left, but I have a seizure. Will it crash?
Yeah, so actually right now we see this every time we apply it. There is misreadings, there's a lot of noise in the signals. But ideally, if you would not create those specific brain patterns with which you can cause something to happen, then ideally nothing would happen. That's basically how it is designed.
So it's very complicated, it sounds like, but it's also very cool. What were some of the challenges you faced in creating this experiment?
Well, obviously the challenge really was the fact that you don't have absolute certainty about the user's intention.
That's not something people like when they fly. Let me just throw that out there.
Exactly, and this is also a reason why we won't see this applied in safety-critical applications such as aviation. So this is a great challenge. That there's, I don't know, it ranges, and some people don't even have control, and this is really, really difficult. You see, it's like oscillating a lot, and to really read the intention, you can obviously do that. You can filter, and then you can make decisions on a higher level, for example. When you think of an autonomous car coming to a crossroads, for example, there's a research group in Berlin who demonstrated that, and you arrive at that crossroads and you give the user some seconds or minutes even to decide on which way to go, left, right, or straight. And if you give this time, you can do a lot more sampling, a lot more filtering, and then you get more certainty, but that obviously limits the kind of things you can do with this technology.
What are some of the other applications besides cars or exoskeletons?
Right, there's cars, there's exoskeletons, airplanes maybe in the far future, but I think it will be interesting also to see probably games based on this kind of technology. And this may also bring a new dynamic into this development if people start playing games with this. Yeah.
What is the reception that this has received in the scientific world? How are people reacting to this research?
Okay, well, obviously this is not something you would see every day on a scientific conference, and which is interesting. I get most of the time people are they are interested, they want to know how it works. They are just like the dialogue we just are having, that's what I usually have also at scientific conferences, right? They are curious, yeah.
What made you choose such a seemingly difficult goal? Why didn't you start smaller with hands-free shopping carts or something?
Right. Yeah, the goal is high. Obviously, you sometimes need to choose high goals, and on the other hand, as I said, this is also about a dialogue, starting a dialogue between different disciplines. For example, in our case, we have, well, I'm an aerospace engineer, and from my point of view, in aviation, we had the problem of how to control machines already for decades. And now we have some new technology, and the question is again, well, how do we enable the human being to control a machine with a new technology? So maybe you can transfer some of the methods that were used in aviation to this new problem.
So you have an aviation background. When you were coming up with this idea and you realized you were going to need input from neuroscientists, for example, and I don't even know what other fields, how did you go about convincing them to be part of this interdisciplinary project?
I think it's the key is the same curiosity that most people have when they hear about this. Obviously, the neuroscientists, they already do work on this technology for some time, and they have other goals, maybe, but they are especially focused on applications for physically disabled people, which absolutely makes sense. But once you find curious people who want to try something new, then you achieve some project like this.
When you have a good idea, it sells itself, doesn't it? Okay, Tim, it's a really interesting idea. I want to open up the floor to our audience if anyone has a question about hands-free flight that you would like to ask Tim. Here we go, over here.
Yeah.
Can we get this microphone turned on, please? In the back, thank you.
1, 2?
Yeah.
Hello, my name is Daniel Vincent from Airbus Defence and Space. I'm curious to know what was the feedback from the pilots based on that first.
Well, as I said, we had pilots who had no control, so they were kind of disappointed. And something else was quite interesting. We had some really, really professional pilots who did not really manage well in this scenario, but some others who were not well trained and they performed much better. And then about the feedback, well, if you ask airline transport pilots, they are more reluctant to change, I guess, or probably most of people are. And they don't see this as a future technology for piloting airplanes. But there are, again, quite a few curious people, also pilots, who said, hey, yeah, I want to try this out, and this is interesting. This could be something one day. Yeah.
One more, go ahead.
You need to think about a lot of things at the same time. How do you tell the people to what to focus for? Because you can't tell anybody how to think.
Yeah, that's actually really difficult. Yeah, that's part of the training. Yeah, the training part I spoke about. You have to learn how to do this. Yeah, how to create those brain activity patterns. But you do nothing else when you learn, for example, how to play a sport or play a musical instrument. Yeah, you learn how to generate specific brain activity patterns that, in that case, cause your muscles to flex or something. But in our case, it would be a reaction of the airplane, and this could be quite natural.
Thank you.
All right. I'm afraid we're out of time. Tim Fricke, thank you so much for being our guest today and telling us about the future of hands-free flying. Let's have a round of applause for Tim.
Thank you for having me.